In today's video, we're going to make our first project on the budget makerspace. We've set it all up, got everything ready. We have our PC, we have our 3D printer, we have our desk, and now we're ready to make our first project, which is going to be a desk-mounted holder for our headphones. Now guys, this is going to be a long video with multiple different sections, so timestamps in the video description to get you to the section you want to see. But without any further ado, let's get started. Alright guys, so before we get into any 3D modeling software, we have to draw what we're going to make. Now as you can see here, I just usually store my headphones like on this piano stand, and it's really a terrible solution. So I ideally want to store my headphones on the edge of the desk like this, out of the way. So before we do anything, we need to draw our idea. So I've got here my sketch pad. I'm going to open up to a blank page. Here we go. Nice blank page there. I've got my pencil and I have my calipers, which we covered in our tools video. Now these are just very cheap calipers, but they should do the job for figuring out the thickness of our desk. And then we should be able to draw what we want, get some measurements, and then we'll fire up in this episode Tinkercad to draw our model, and then in another episode we'll look at Fusion 360 to design a slightly more complicated headphones holder. So this is the idea that I've got. I want it to be kind of like a C shape, like this, with a little thickness up here. Then I want it to dip down a bit, stick out, and then dip up again, come down here, and then just be like that. So really, this is a really simple idea. This is the desk here, and this is where it's going to sit on. So I want this distance here to be the thickness of the desk, because I want it to be a press fit. I'm designing this specifically for my desk. This doesn't have to be a multi-purpose universal design. It is for my desk, so I'm designing it exactly how I want it. So with that in mind, I'm going to just draw it really basic and get our measurements with our calipers. So again, we've got our little cup here, like this. It goes across, down, like this, up like that, down, like this, and like that. Okay, so this distance here, I'm going to measure with my calipers, and what's that going to be? So you can't see it, but it's reading 15.4, 15.3. I'm going to go with 15.4 here, so 15.4 millimeters. There we go. And then we need a certain depth as well. So you can mark that easily by just doing some dotted lines like this. The dotted lines can meet up like so, and you can figure out the distance there. So that distance you can make up, but I'm thinking 30 millimeters looks to me like a good distance from the edge of the desk. So I'm going to make that 30. And this thickness here of the material, we don't want it too thin, we are 3D printing, so I'm thinking 5 millimeters will be nice and strong. We're only going to print in PLA. And again here, 5 millimeters. Now it needs to be read by you. Don't forget, you're designing this for yourself, no one else. This distance I don't really care, so I'll leave that up to my design decisions when I fire out the software, but this distance here is important, so I'm going to figure out here what my distance should be, and it's based off my headphones, so the headrest here is 23, 24 millimeters, so let's give it a healthy amount of space. Let's make that again 30. 30 looks good, just in case I get some thicker headphones in the future. So let's go with 30 millimeters there. And this dip here, I don't really mind. We are using Tinkercad, so it's not as accurate as Fusion 360. So I'm just going to say, that distance should probably be about, let's go with about 8, or let's go 10 millimeters. So 10 millimeters, and I'm going to make those the same height. So 10 there, 10 there, and this distance here, for a decent amount of strength, let's go with, let's go with 13. Now this is just a rough guide. We only really care about these and that. These ones are just to inform our decision, but this is a really basic design. and I'm just going to extrude it as it is. Now, with this, there is a top view as well we need to consider, and the top view will explain how thick this design should be. So our top view for this, if this is the side view, our top view, if I draw it up here, will be like kind of this. So I'm thinking I want it to narrow down for this area, which is up there. But this area here determines how thick it's going to be. Actually, you know what? I am designing this, and now we're drawing, I can realize as I'm drawing that this area here is going to need support material. So let's actually just make it a uniform thickness right across. So the whole thing is going to be a uniform thickness, extruded out, really easy to print. We need good printability. That's why you draw things, to figure out these things before you start designing. So a good thickness, in my opinion, will be, yeah, you know what, like 25 millimeters looks more than adequate. Actually, let's go with 24. So 24 millimeters thick. And this is our top view and side view. So there's my really rough sketch. I'm happy with that design. I'm going to fire up Tinkercad and draw this up, and then we're going to print it out on our TronXY X1. Let's get started. Okay guys, we are now in Tinkercad with a new blank work plane to draw our headphones holder. So Tinkercad is designed for kids. It's been expanded on massively. It's now owned by Autodesk, but we're going to use the most basic way of modeling in Tinkercad, which is using primitives to add and subtract to make our shape. First, before we do anything though, we need to drag a ruler in, and this is going to be our origin, which will let us measure and precisely enter dimensions into our shapes as we bring them in. So let's start with a box. A box is what we're going to start with, and if we look at our design, we can use a box here, this component here, to then subtract a box away to create our clip, and then we can do a few more primitives to create our holding components. So let's start with the clip. So how do we figure out what size this box needs to be? Well, it's going to be 15.4 plus 5 plus 5, which is 25.4. So let's enter that. Right click to move down. We need to enter it for our height here. So 24.4, enter. Looks good to me. Zooming and moving around with the mouse wheel and right click. And then our design requires it to be a minimum thickness of 30 plus some meat that we wanted to draw in. So I'm going to add 40. That gives us 10 millimeters of extra meat at the end there. So let's go with 40. And remember, we have a certain overall thickness of our design, which is going to be printed, and we set 24 millimeters for that as well. So 24 is going to be here for overall thickness. Here we go, 24, enter. And you can, of course, figure out where it is from our origin, our ruler. It's 22 by 15 in the X and Y, so I'm just going to move it down till it's right in the corner there. 0 and 0, so the corner is right on our origin. Excellent. Now we need to create that cutaway, and you can turn any shape into a hole and any hole into a shape in Tinkercad. A hole is something like this. It's a negative of a shape, and we will use this to group and cut away our gap, which makes our little sort of C shape. So we're going to use that to create the internal part here. So that's 15.4 millimeters in height. So here, I'll just move it out of the way so I can get to it easily. 15.4 millimeters in height. Again, our depth overall is 24. And the depth into the actual holder, we've set at 30. We said 30 was a good amount to go onto the edge of the desk to get good purchase. I'm pretty happy with that number. Remember, you can tweak even at this stage, don't be afraid to. Now we have our void that we need to cut away, but you'll notice it's in the wrong place in the Z direction. We need this to be 5 millimeters up to make that nice C shape. So we can do that by grabbing the little black dot here, black arrow, and moving it up, and you notice the actual number here increases as we move it up. So you can see increases there, and we can actually just enter precisely 5, which makes it 5 millimeters from the 0 of the Z plane with our ruler. And we'll put this in place in our shape. So keep in mind we want the corner to be 0, 0. So keep in mind we want the corner to be 0, 0 on the origin like our original shape. So 0 and 0. Okay, well there we go. It looks pretty crazy because it hasn't been grouped yet, But that, if we zoom in here, is going to be our cutaway. So to group these two shapes, you select both of them holding Shift, and then over here in the top right, group. And that's going to cut away to leave our grippy C shape. And that's going to be what holds our headphones onto the desk. Remember, we made it exactly the same size, so it's going to be a bit tight, but it will hold our headphones really nicely on the desk. Okay, next, we want to do the exposed part where the headphones sit. And we said that 30mm was a good amount of purchase for the band to sit on, and then we've got a little bit on extra, which we can make to fit. We can make the size whatever we want, really. So I'm going to grab another box in this case, and let's just put it there for now. And we want it to be 30mm long. But the depth this time, we want it to be not very deep. I think we decided 13mm was a good depth. So let's go with 13, and we'll move it up. Okay, now we did specify a height here from this component to here as 10mm on my design, but now I'm looking at this model with the actual accurate dimensions, and I'm thinking 10 might be a bit too much, because if we do a bit of maths, 10 brings it down to, so it's going to be 24.4 minus 10, which is 14.4, then minus the height of this, which is 13. It's going to bring it down to 1.4mm if we enter it here from the bottom, 1.4, and that doesn't look too great to me. So I'm actually going to just enter 5 here, which in my opinion looks good. Again, this is a good starting point, but we can tweak it if we need to, and that looks good to me. Now this has to be the same width as our original, which is 24mm. So here where it says 20, that needs to be 24. So now we've got the height we want this headphones holder component to be. We need to move it into place. So again, working off our 0 origin, you can see that it's 2mm from it. So we're going to enter 0 to make it onto our origin. And it needs to be touching this shape here, which is our original holder, which is 40 millimeters long. So obviously this number here needs to become 40 as well. So it's touching it perfectly. Hold down Shift for both, and then we group again. Alrighty, so far so good. We have our very basic holder, but if we put the headphones on it, they're just going to slip off, which is not what we want. So we want something to hold them in place, and I'm thinking a wedge would be nice. Now, the thing about our design so far is the wedge would just be sticking off the edge. So we need to give our holder a little bit more distance to then put our wedge on to allow for it. And that's okay. You can ungroup in Tinkercad, so we can modify it. So I'm just going to select our shape and then ungroup. Select our box again. Now we set 30 and we need that 30, but I'm going to allow myself 10mm of extra material to add our little wedge to stop the headphones falling off. So 30 to 40, like so. And then again, hold down Shift, select them all, and group, like that. And now we can grab our wedge, and I know I've allowed 10mm of extra room. So with our wedge here, we can actually just grab that. We actually need to rotate it, which is a little bit interesting in Tinkercad. So with the little rotating arrow here, you want to make sure you indent it. You don't want to have it just rotating every degree. You want to make sure you indent to these locked positions. So just move the mouse to them, and we want 90 degrees like that. Actually, we want it the other way. Let's rotate it all the way around. So we allowed 10mm, so let's change our thickness of this to 10, like that. The height's a bit extreme. Let's make that 10 as well. Why not? 10 looks pretty good. And again, we need our width to be 24 to match our overall shape. And it's obviously completely in the wrong place, so I'm just going to move it up roughly to figure out where it needs to be. Oops. Move it up like this using the black arrow. We can move it across to roughly figure out where we want it. So don't forget that this shape was, if we ungroup it again, it was 40 plus 30. So that means we want this wedge to be 70, which is, we actually moved it into the position, but 40 plus 30 is 70. So you do a lot of little maths calculations in Tinkercad. It's not clever enough to do the things that Fusion 360 can, but it's a lot more accessible. So that's correct there. And also the height is important. So here with the shape, you can see we've got 13mm high, plus 5. So 13 plus 5 is 18, which means that this shape here needs to be 18 millimeters off the ground. So we've actually done a good job just moving into place correctly. But if you have any doubt, you can check these dimensions. So I'm really happy with that actually. I'm going to select everything. Now I've got multiple shapes. I can even do Control A. Control A selects everything in the workspace, and then group. But we're going to customize this just a little bit so you have something that is truly yours. And to do that, we're going to put some text on it. Now, to do this easily, I'm going to actually move my work plane to the top of our headphones holder so we can easily place text directly on it. So here, work plane, I can actually just drop a work plane here on top of our headphones holder. So now work plane is at the top here. This is good practice to get into if you start using other CAD programs, by the way. And then we want to drag some text in to the top here. Now, this is important. We need to change a lot of things. Firstly, the size is way too big. So let's scale it down. Hold down Shift, by the way, to uniformly scale, which is very handy. Like so. And we're going to want to enter something. So I'm just going to do 2 M's like that. So it's going to be a Maker's Muse headphones holder. But you can enter whatever you like. And you could be precise with this. You could use the Align tool if you so choose. But what I'm going to do with this, in fact, is actually just emboss the model by 0.3 millimeters. Very small. So you see this height here? I'm going to enter 0.3. It doesn't look like much, and it isn't, but you will still see it. Maybe 0.5. 0.5. There you go. Okay, I'm happy with that. Now I'm going to select both and group. And our model is complete. So to save as an STL file for 3D printing out of Tinkercad, it's very easy. You just need to go over the right here to export. And you want to export it for 3D printing. Make sure that you don't have anything stray in the scene like other random boxes and and spheres and things that you don't want to export. We're just exporting this. So it's going to export everything into design, which is just one thing. And we want to export as an STL for most slicing programs. This will now download as whatever it's called it by default. Tinkercad calls things silly names. So we've got Tremendous, Usam, Crunk. You can change this if you so choose. I actually like to leave them as default, but you can change it if you like by just hitting here and then changing. So like you can headphones holder, whatever you like, and it will download as that name in the STL, but I actually like the random names. So we've got our STL file now downloaded. Now we need to fire up our slicer. Now you can choose any slicer you like. Check out this video for my list of top 3 free 3D printing slicers. But I quite like Ideamaker. So I'm going to download Ideamaker, the latest version, and I will rendezvous with you once it's installed now. Welcome back. We now have Ideamaker downloaded, installed, and fired up. Now Ideamaker is, if you would have seen the other video on the top 3 free 3D printing slicers on Maker's Muse, Ideamaker is a fantastically powerful free slicer for your printers, and it doesn't just have to be used for raised 3D printers. Now I've already configured my TronXY X1 for Ideamaker, but I'm going to run through how I did it. So you want to go, if this is the first time it's fired up, to Printer, and then Configuration Wizard. We're going to select the extents and the characteristics of our printer. So you're going to go to Printer Type, go all the way down, and I said I already have the X1 here, but let's pretend I don't. Let's go to Others. Now I'm going to do a new printer. I'm going to call it TronXY New X1. Why not? You're going to set your nozzle diameter. That's important. If you've got a 0.4 nozzle, which most of these printers come from stock, you set that. If you've changed it to a larger or smaller, you need to tweak this or your prints won't work. Now, build size is really important. The TronXY X1 has a very small build volume of 150 by 150 by 150. And steps and millimeters, don't change that. You'll just leave it as default. And we don't want to do any compensation. That's, scaling compensation if sizes are not correct. You don't want to do anything here. Leave it as is, and we need to tick if we have a heat bed or not. My X1 does not have a heat bed, so that is not ticked. Then we go to the extruder count. We only have 1 extruder on the X1, so that's fine. It's easy. We can offset how far it is from X. We don't want to offset it at all. And in fact, we don't even want to offset it from Y. So that's 0 there. And then primary extruder. So we don't print in 3mm on the X1. We print in 1.5, and it is PLA. So there's a good default to go with. And okay. So there we go. That is our new configuration for the TronXY X1. I'm not sure why it goes through this again. We just set it But there we go. A much smaller print volume with our new profile. Now you will still have to tweak speeds and temperatures and etc, but this is a good start. So grab your file from the downloads folder and insert it through the add option here on the menu, and you'll notice as it comes in as we designed it in Tinkercad, which is not suitable for 3D printing. We need this to be rotated by 90 degrees. Now you might choose to design it as it should be printed in Tinkercad to save you a little bit of time, totally up to you, but rotating in Ideamaker is very easy. You just go to rotate here, and then we're going to enter a specific amount. So we're going to enter here, which I believe that would be the y-axis, because there's the red there to let you know. We're going to rotate that by 90 degrees. Oh, that's not the right one. Okay, 0 to reset. In that case, x-axis, 90. Okay, sometimes it takes a bit of trial and error to figure out which axis is the one you want. Sometimes it does take a bit of trial and error to figure out if you want the y or x-axis, but you can easily just reset it. So there we go, I'm happy with that. And we've got our model rotated around on our print surface. So we now need to slice and choose our print settings. So to do that in Ideamaker, you go to Start. Now we don't have any profiles ready, so we're just going to hit Duplicate to create a brand new one. This is going to be our default, and I'm going to call it 0.2 millimeter because that's the layer height I'm going to choose. Okay, infill density 15, whatever. We're actually going to go into advanced. So advanced. These are all the settings you have access to now. Now, don't worry, you don't have to change most of them. Really, all we care about is our layer height. That's how coarse layers are. So 0.2 is a nice medium layer height, not too rough, not too fine. Default printing speed. Now, the TronXY doesn't want to run too fast, so 30 millimeters a second is a good default. You may want to go faster or slower, depending. And infill is at 40, it's a little bit faster, and movement is at 100. That, again, is a good speed. I wouldn't really change these off defaults to start with. You can tweak them if you think your machine can go quicker, or you can change them to be more conservative if you need to. First layer height, that's important. It's the first layer, and the TronXY does not have a heated bed, so we can actually change how much material comes out of our first layer to help it stick better. So 105% is actually a little bit more. If you find you get what's called elephant foot, where it bows out too much at the bottom and then sort of comes back in, you can reduce this, totally up to you. But my first layer speed, I'm actually going to set at 15 millimeters a second. Nice and slow to let that first layer really stick down and let me tune it if I have to before anything goes wrong. Infill settings. Again, I'm going to leave these as default and you can change them, but I'm quite happy with those settings. Grid is a good infill type. There's not many options in Ideamaker for infill, I will be honest, but again, it's totally fine. And let's go 15. That looks fine. And support, we don't need support material for this print, don't worry about it. So it's not going to be turned on. Raft, that is a piece of material under your print if you have problems with bed adhesion. We don't need this, we're not going to worry about it. Now cooling, this is important. We're going to figure out our temperatures. We don't have a heated bed on the TronXY from the factory, so bed temperature is 0. And we need to figure out how hot we want the extruder to be. 210 is a little bit hot for PLA in my experience. I'm going to make that 200. You might want to change that if you like. And then fan control is our cooling fan. Now, the TronXY from factory does not have a cooling fan, and I haven't added one yet. But once you do and plug it into the TronXY's Melzy board, you can determine when it turns on. So first layer it won't turn on, then second layer it does turn on at 100% speed. That's important, and you can tweak this if you like. Again, defaults are very good. Retraction will help you reduce stringing issues. Now, I've done a whole video on retraction you can check out here. It was done in Simplify 3D, but it's very universal in what I changed, and you can tweak these settings to get better retraction. Not quite sure why wipe wall is ticked in default. I don't really want that, and we don't want to wipe tower. That's only really if you're doing dual extrusion, and any of these other ones, just don't worry too much. We're doing basics, guys. Under other, we have some really weird modes like spiral vase, where it will do just the outline continuously, or you can merge or separate models if they're intersecting. I did a whole video on that as well if you're interested, but I'm not going to worry about that. And also we can tell it to pause if you want to change colors, for example. Very powerful, don't worry about that. And then finally we have G-code, where you can change your stop and start G-code. The default is to home the machine. So we have G28 homing, it will home X and Y, then home Z, and then it will start printing. So that's totally fine for me in my experience. It's going to do a little bit of a purge by the looks of it with the E30 there, and it's going to start printing. And then at the end, it will, by the looks of it, turn everything off, and then home X and Y, but not home Z, which is good, and then turn the motors off. Okay, that's fine. Don't worry about changing your G-code of default. I'm happy with that. And then I'm going to say we don't want supports and we just want a brim. Okay, we have our first profile. That's Slice. So you can see how fast Ideamaker was, very, very quick there, and even gives you an estimated cost. You can enter how much a filament costs, and it gives us a time and material estimate, so 18 grams, 6 meters, and 1 hour and 30 minutes, which is quite long, but it is the TronXY. We are printing quite conservatively. And as a preview, we can check out to look at our model. So this is the print preview, which I love the print preview. It's awesome. So you can see here as the model will form, it's going to be quite nice and stable there. We'll have that nice M there. Excellent. All right. So let's save this onto an SD card, send it to the TronXY, and get it printing. Okay guys, so we've got the TronXY X1 here, and I use a glue stick on my print surface to help stuff stick down. It works really, really well, so grab yourself some cheap glue stick so you don't need a heated bed for the TronXY to print PLA. I've got this spool holder I talked about in the previous video that works really well on this TronXY brand filament. And I've got the SD card loaded in the back here. Micro SD, it's a bit fiddly, bit of a pain, but that's okay. Okay, so we need to now send the file to the printer, and the TronXY menu navigation is just shocking. So you need to go down to SD card, cross, down to unmount, then mount, up, print file, and then you need to select our model, which will be down, right at the bottom, right down there. There we go, Tinkercad headphones, and then across to print. So it's going to heat up to 200 degrees C, and then start printing.
Now you can explore microscopic worlds.
And that is going to do it, guys, for our first project on the budget makerspace. I am stoked with how this turned out to hold my headphones. It's a very useful little 3D print, and I've walked you through the entire design process from idea to sketching and measuring to modeling in Tinkercad and then printing it out on our budget little printer, the TronXY X1. Now there will be a follow-up video to this with me designing an alternate version in Fusion 360, so you can see if you prefer a more advanced 3D modeling bit of software or if you'd rather stick with Tinkercad. But either way, I'm really stoked with how it turned out, and I hope you guys enjoyed this video. My name is Angus, and I love to empower your creativity with 3D printing, and I love to provide this content to you for free on YouTube. All I ask in return, if you enjoyed this video, is a like and maybe consider subscribing so you don't miss any future content. Look forward to seeing you again very shortly here on Maker's Muse. Catch you later, guys. Bye.